All right, guys, last example for today. Example 5, it says write vertex form when a is not equal to 1. So right away, guys, if we just jump to our equation, the only time that we're going to use this process that we are about to do is when this value right here, the number in front of our variable squared, if that is not equal to 1, so this time it's -5, that's when we're going to have to do this extra process that we're going to see in example 5. Otherwise, you guys, in every other example we've done today, our a values were just 1. And if they're just 1, we can still use the same processes as before. What we're going to do does not happen often. Most of the time, a equals 1, and the process is a bit more simple. If it's not 1, though, we're going to have just one big extra step that we need to do. So let's go ahead and take a look. So we have astronauts that are training for flying in zero gravity using special planes. A special plane that flies in parabolic arcs. The graph shown approximates the altitude a in meters of a plane in relation to the time t in seconds during a training session. What is the maximum altitude reached by the plane, and at what time does the plane reach its maximum altitude? All right, guys, lots of crazy words. What really sticks out to me and what I'm hoping sticks out to you guys too is that word maximum. To us, maximum means vertex. That is our goal in this question. We just need to take our equation and we're going to have to put it into vertex form so that we can then identify the vertex. All right. What we did in example 4 is exactly what we're going to do in example 5. There's only one extra step we have to do. And you guessed it, it has something to do with this a value here. All right, so first step, just like we did before, we want to get rid of that c value. The c value that we start with is not going to give us a perfect square trinomial. So we need to subtract it away, move it over to the other side. And when we do, now we have a minus 9,000 on the left-hand side. And on the right-hand side, we're left with -5t squared plus 80t. At this point in our last example, we were ready to add our blanks on both sides. Now, here's the kicker with this question. At this point, what we need to do is to factor out this a value. Let's make a little note to ourselves. Factor out a value. And good news is it will always be factorable. So really, we just want to move this away. And to do that, we're just going to bring it out front and figure out what the rest of the inside of our parentheses looks like. So we're going to divide this by -5. And when we do, we're just left with t squared. Same thing, let's divide this by -5. And 80 divided by -5 is -16t. So only on the right-hand side, we factored out the a value. Because now, look at on the inside here. My a value is 1. Smiley face, that's exactly what we want to happen. All right, so that is our only new step, you guys. We have to factor out that a value. Let's go ahead and bring down what we had on the left-hand side again. And at this point, we are now ready to add in our blanks. So the blank on the left-hand side, we're just going to add that in like normal. Add in our blank. On the right-hand side, though, we have to add it on the inside of our parentheses. So we want to add that on the inside here. All right, so let's go ahead and focus in over here. We have a new b value, and we want to use that to find our perfect square, our magic number that will go on the purple blank. So to find that, we do -b divided by 2 squared, -b divided by 2 squared. -16 divided by 2 is -8. And -8 squared is 64. So that's our magic number, 64. And we can add it in on the right-hand side as long as it's in our parentheses. But really, you guys, what that number is, what our real magic number is -5 times 64. Sorry, I don't know why I made that straight line. There we go. Negative 5 times 64. So when we add that number on the other side, we actually have to multiply those. So instead of just adding 64 here, we have to do negative 5 times 64. Let's make a little note of that. This is the magic number times the GCF, 5, negative 5. All right, so we added in our blanks on both sides. On the left-hand side, we're always going to have to times that magic number by our GCF that we factored out. Now let's see where we can simplify. Let's go back to the right-hand side. We still have negative 5 out front, but now on the inside of my parentheses, I should have two perfect numbers that multiply to C and add to B, and that number is negative 8. Negative 8 multiplies to 64, adds to negative 16, and now we have our binomial squared on the right-hand side. All right, let's bring down that equal sign, and now let's see what we can simplify on the left-hand side. So we're going to have to times these two numbers. Let's go back to our calculator. 5 times 64, negative 5. We're going to get negative 320. And the a variable, we're not going to be able to add that to anything. So really, we just need to add negative 320 and negative 9,000. And when we do, we get negative 9,320. Let's zoom out, see where we're at now. We are super close, you guys, to our vertex form. Our last step is we have to isolate A. A serves as our y value, as before. So our goal is to just isolate that variable, and now we have our vertex form. Let's go ahead and rewrite this off to the side. A equals negative 5, our binomial squared that we found using completing the square. And now we just have plus 9,320 on the outside. And to answer our final question, our vertex is H, comma, K. This is our max height. We'll do H for height. And this is our time that we reach that height.